So today I'll be discussing a concept called biomimicry, where biomimicry or biomimetics. So what it basically means is that how can we learn things, particularly science from nature, and then bring those concepts in our modern technology that will be highly useful for humanity and mankind for their various kinds of needs. So this is a kind of logo kind of designed by one of my students. She's here, Anugraha. And basically this tells us that, in this green part, you can find various things you can find in nature, and these are the some of the technologies one way or other adopted some of these concepts. So this is just only a few examples. You can find numerous such examples where the technology basically has been motivated after seeing some of these things in nature. It can be kinds of the structures in nature. It can be some of the species in nature, or various plants, or so various kinds of things can be kind of inspired from nature and then can be implemented in our modern technologies. So I'll be discussing some of those kinds of concepts. So when I talk about when I talk about the biomimetics, it has implications or importance in various aspects of human life. So it can find applications in engineering. I will discuss some of those engineering aspects. It can find architecture applications in architecture, how the nature built some of those structures, and how can we use them adopting this concept. How can we help in modern architecture? I also will give some examples, and some of the parts I am not going to touch is something like art and medicine. So this biomimicry or biomimetics, mimicking things in nature, adopting the scientific concepts has lots of implications in human life, and I'll be discussing on the materials aspects of those. So the question is like, why materials, right? So that is one of the things. So those who control materials control technology. It's basically stated by one of very senior advisors of Panasonic. It's really true. The current technology, whatever information technology or the biotechnologies, imaging technologies, whatever the technology existing today is basically happened because of innovations in materials. So when I say innovations in materials, materials can be engineered in different ways. The size can be engineered, and shape can be engineered, and then the type of the material can also be engineered. So all these engineering technology, for example, last year Nobel Prize in chemistry, we all are benefited out of that Nobel Prize, because most of the time we never get direct benefit from a Nobel Prize. But this is the last year Nobel Prize for lithium-ion battery discovery was one such concept. We directly benefit the humankind, and that revolutionize the gadgets, right? Electronic gadgets. For only in 1991, the Sony came up with the concept of rechargeable lithium-ion battery, and the works from those three scientists, those who got Nobel Prize last year, basically resulted into the discovery of such a rechargeable battery. So there were issues with the materials. Using lithium as such in a portable electronic gadget was a kind of very difficult with safety aspects. But they came up with the new materials, with the new concepts, which can be adopted for rechargeable batteries. So new materials are always important for technologies, and this can be engineered by size, shape, type, and all these are important in developing materials for technology. Now, when I talk about size of materials, another word we all might have heard a lot is nanotechnology. So nanotechnology is nothing but manufacturing with atoms, playing with atoms. Now, the word nano is just like milli, micro, it's just a prefix, meaning it's dwarf. Or in other sense, it's around, we are talking about sizes of the order of 10 raised to minus 9 meter. So I will come to the kind of concepts of size, but before that, nanotechnology is nothing but, you have lots of plenty of atoms, and let's say Lego, and how do you make very beautiful structures from Lego? If you the right block at the right place can give very beautiful structure, right? So this is a very similar thing. It's you have atoms, and combining different atoms in a very beautiful manner, build them to get a structure. This is basically is nanotechnology. But it is a tough Lego game in the sense you are playing with atoms. So that's one of the toughest part of that. But exactly, it is what we do in Lego is what we are doing in nanotechnology. So I told you the word nano means, the Greek word has the meaning of dwarf. So how much dwarf? How short they are? So a human hair is approximately typically of the order of 10 micrometer, 100 micrometer. So what we are talking about, the sizes of the order of 100 nanometer, so much smaller than a human hair. So if I take a human hair cross section, 100 micrometer is a human hair, and a very small part of that will be 100 nanometer. So 10 raised to minus 9, and micro is 10 raised to minus 6. So there is a 3 order change. So 1000 times less than the size what we talk about a micrometer. If I talk about the similar sized nanostructure, one of the first nanostructure people have studied quite a lot is a ball-like structure, or you can see here a carbon 60 containing 60 carbon atoms, known as C60 or fullerene. So so if I talk about the size, why size is important? That's another question, right? Why size is important? Now, so what happens when you come down in size? So this is a very simple illustration. Like 1 centimeter sized cube has, we all know 6 centimeters square is the area. Keeping the same volume, if I make this 1 centimeter cube into small blocks of 1 millimeter, the volume is same. It will be the area, total area will be 60 centimeters square, 60 centimeters square. But at the same time, if I make them smaller, it's 1 nanometer cube, keeping the same volume, then you all know that the surface area, you can just keep the same volume and calculate the area. It will be 60 into 10 raised to 6 centimeters square. So this, in one way or other, we are all doing in our daily life, making the big pieces of wood into smaller. We are making the combustion faster, easier, and making the burning effective and for cooking. So this is the same thing. If I take a bulk material having a volume, given volume, making it smaller, the volume is same, but at the same time, the area we are increasing. And this by, you have an enormous surface area. And when you talk about atoms, the enormous number of atoms are available at the surface for reactions. And this makes nano very special. So this is what happens when you bring down in size, not just in size, this can have other important things. It will lead to very other interesting properties. Some of them I will discuss. So this is one of the implications of size, making the size smaller. into the of the order of a few nanometer. Now, the interesting aspect of this is that you can find such examples in nature. Some of the structures like seashells, seashells, what you call in shank or calatre. So it can have a very beautiful shape, and also it can have a very interesting color. Now, why it is very interesting? So if I look into the material, it is nothing but calcium carbonate, but not a calcium carbonate block. It's a chalk, right? Calcium carbonate is a chalk, but not just a calcium carbonate bulk thing. The way the calcium carbonate arranged in this particular seashell is very interesting, and the shape is interesting. I will come to that point again. And the material is like a same chalk kind of material, and instead of in between these calcium carbonate bricks nanostructured assembly, you can have very soft polymer glue, very soft biological polymer glues. And so this has an enormous strength. So because some of these seashells, most of the seashells are forming very underneath in the sea. So this basically they are actually facing enormous pressure, and they are in different conditions of high saline condition. So the condition also varies a lot. So they are surviving all these conditions because of a very special structure. So not just the material, how the material arranged is also important. And beautiful colors. Colors has a different reason. I'll come to that point also. Now, if I look into whether the mankind were known about this technology or not, so you can see in very old Roman era cups. So there's something called a Lisardus Cup. I mean, this is, I'm sure many of you might have heard about this. And this has a very interesting coloring, in the sense, like if you put the light from front and back, it has a different color appearance. And then when scientists looked into that, and they knew that, this color, these are not color pigments that you normally use, chemical based pigment, but they are nothing but some nanoparticles of metals like gold and silver. So so the very interesting concept. Now we know that when metallic particles like gold, in bulk, gold is in a yellow metal, right? So yellow metal is well known and yellow metal. But when you bring down the size into certain nanometers or so, the color changes. So size dependent coloration. Somehow people were known about this quite long back. You'll be quite surprised. It's quite surprising, but we don't have any kind of documentation whether they really knew about the science. Definitely they might have some kind of know-how about the technology or the aspects of size, and even in the 4th century AD. But now we are using these things in many forms. I'll come to that also. Now, there is another very recent report from Tamil Nadu. So this is basically came in NDTV, and later it was mentioned in many other newspapers. Very ancient pots having dated 600 BC was unearthed, and they found a very interesting carbon coatings on these things still existing. You see 600 BC pots and still having a black carbon coating on that. When scientists from Vellore Institute of Technology, when they analyzed the material, they found that it has something called carbon nanotube, tubular forms of carbon. So initially I showed you bold kinds of carbons. So it's called fullerene, and this is a tubular forms of carbon known as carbon nanotube. So, and they might have, so this kind of material, carbon having sp2 hybridization, having a tubular structure, is now known for a very high strength material, giving a very high tensile strength and also very high thermal stability and also good thermal conductivity, etc. So even in that time, somehow people were known about these concepts. That might be the reason. If I use just a black powder or carbon powder, this will not have a property of this of high stability and mechanical stability and thermal stability. But they use a highly crystalline form of carbon known as carbon nanotube, and they knew it and they quoted it. But there is no documentation how they might how they have synthesized or so. But somehow they knew about it. But this in lab was developed only later. When this is my professor, and when he was at Japan, he was the first person who was basically discovered the so-called carbon nanotubes in 1992. So it took now we know how to make it, in a large amount, how to engineer them in large amount, etc. So the technology is now well understood, but somehow people were using these kinds of very interesting nanomaterials and also very structurally interesting materials for the right application, probably for the right applications. But we lost in between how they got in this technology. So now this is my PhD work. Now we know how to make large amount of these carbon tubular forms of carbon. It's just like a pipe. It's like a PVC pipe of carbon, sp2. So many of you know about the carbon hybridization, sp2 hybridization. And and now not only synthesize, you can engineer them. So this pipe, as I told you, this is like a PVC pipe, so you can fill this pipe with other material. So this here we have filled this carbon tubular form of carbon. This you can see, this is 100 nanometer. So this diameter is around 150 nanometer or 200 nanometer, and this PVC pipe can be filled with other nanoparticles having smaller size. So this is I filled with magnetite, the magnetic powder, magnetic iron oxide powder. So what will be the application? So one of the applications we tried, we wanted to try the growth of a plant, and then we basically injected into the seed, and after the growth, and we studied the leaf of this plant, and we found that the leaf has the magnetic property. So that means that the carbon nanotubes, whatever we have injected, reach the plant. This will really help, something kind of MRI kind of study, to look into the imaging of the leaf using these kinds of magnetically trackable particles. And other applications was coating with sand for water purification. I'll come to that point later. This thing. So what I want to tell you is that this is basically science, right? Science is nothing like just brag by stating that it was we were known. I mean, our old generation were knew about this technology, but but we don't know how to use it. But that's not science. But science will be called so when we have the ability to reproduce and engineer them. So now we know how to do that. So various other applications. So this is just to catch your attention, like how good, I mean, what can be the applications of such structures once you have this reproducibility and large amount productivity. So one of the things that got the Guinness Book attention was making a smallest brush, very similar to our toothbrush. And because now we know how to make them very effectively at the large amount at the right position. So we can really create these kinds of nano brushes. And the interesting part is there are very small electronic circuitries. So you can see this is an electronic transistor. Having lots of dust. So using a robotic arm, something like this, we could able to basically clean the entire dust covered in that particular area. We cannot use a large brush of typical whatever we use for this application. So that you need to have really small brush, and that is what we are using here. So, and the same material, if I arrange them very well as a sheet, vertically ground. So this is a nanotube sheet, but people found that it can make a darkest material in the world. The reflection from that is almost zero, very close to 0.045% if I quantify them. And so this was the darkest material in 2007 with the same concepts with a much better arrangement perfection. From a group from MIT, they showed that almost 99.995% absorption is possible from material. So you see where is the application now? So this happened just because of the arrangement. It is arranged very well. So the same particle, same thing, when it is arranged very well, you have a kind of 99.995% absorption. You can see this is a diamond keeping with a light. So you can see that, but background there is that particular carbon nanotube sheet. You cannot even see that. So that is the darkest material now. Whatever we have developed, we have means the mankind, the human being developed, this is happened because not only the materials property, but also the property of the arrangement. So this is important, and this will have applications in solar cells also. So now another interesting aspect of this, you all know about graphite. Graphite is one thing we are using in pencil lead. So this graphite, we can use it as a pencil lead it's showing black also when you write? Because the graphite has a very nice arrangement of carbon, and when you write, individual layers or a kind of several layers, a bench of several layers will come off. And if you look into whatever you have written in using a microscope, you can see the arrangements of individual layers of graphite, so-called graphene. The one layer of graphite in a UPSC is called graphene. So several such layers will be arranged. So this, if I take one of this particular layer and make a bowl kinds of structure, this is the first nano material I told you people studied in detail. It's called fullerene. But if I make a tube, a tubular structure, we call carbon nanotube. That is, I have shown you how good the arrangement helps to make a darkest material or study the plant growth or so. And if I take one single sheet of that, it is called graphene. It has an extremely different property. It is completely transparent. There you have seen a material which is 99.995% absorption of light. Here it is 98% of transmission. Okay, so this was a very recent material, few years back, people have discovered very interesting electronic properties. Very good conductor. Electrons will flow like light. So, I mean, this is a very large sheet of carbon. So what I want to convey you here is that all are carbon, nothing but arrangement of atoms matter, and the way it is arranged matter to make to a very darkest material to a very highly transmitting material. A very highly insulating material, for example, diamond is an insulator, very high insulating all of carbon, very high insulating material to a very high conducting material, like what I call here is a graphene. Now, so what can be the applications of such materials? So for example, transparent gadget. So this is a kind of transparent gadget developed, not with the graphene also, it's using a different principle, but still you can see there are different opaque. For example, the battery is still not transparent. Now, another very important application of that, using facial mask. Now we know that facial mask is a kind of going to be a part of our life. But, facial mask is basically covering the entire face is kind of not liking to many of us. But can we develop something which is transparent mask? At the same time, a mask should basically filter out the hazardous particles from coming from the breathing air. But at the same time, it has to be very selective to air. Right? It has to be very selective to air. So one of the other questions is, can we do very selective movement of air only through the mask, but the others are basically filtered out. Can we develop or not? So the answer is yes. Nature does it very nicely, very effectively. So why not us? We can develop some of these concepts using some of the advanced materials. So we have developed a mask, but it's not a completely transparent mask, but something called a very high quality rechargeable mask. So I'll not go into the details of this particular mask we developed, but I will discuss some of these kinds of concepts where we can directly mimic from nature and how do we use them in the lab. But one of the problems with the nano, you might have already seen when I say it is smaller than a hair, human hair, how to handle them. It's very difficult to handle them. So one thing is sure that you need to build a larger structure, a Lego-like structure, which is made of different nanomaterials. But this entire block also should also keep the property of nanomaterials. Okay, so you need to make bulk, you need to arrange atoms to form larger scale of structures, which is easily handled, which has to be easily kind of manipulated or used by us without much training in those particular fields. So how do we do that? So one of such concepts I want to mention you first is a Jaco Tape, also called Jaco Tape. You all know about lizards, right? Lizards climb walls very easily. But I don't know how many of you have tried to pull a lizard from the wall. You need to, comparing the weight of that, you need to apply a large amount of force to pull that from the wall. So it's not easy. So now another issue with this tape is that our tape, it has lots of problems. The cello tapes or kind of tapes what we are using for sticking things, if you do very slowly, it will work. But if you do very fastly, very fastly, hastily, or with a very high rate of pulling and pushing, these tapes won't work. Okay, that you can experiment yourselves. These tapes won't work. Another issue with our tapes won't work in vacuum, high vacuum conditions. Very particularly for the satellite application, for the space applications, they won't work because lots of issues like degassing, etc., will happen. So the normal tapes won't work. But at the same, I mean, we all know that if I have a same tape, if I use multiple times, that also will not work. But the lizards or those kinds of category, they can do these climbing things several times without failing, right? And this is actually they can how it is happening. So when we looked into this fact and when we looked into the feet of one such lizard, and what we can see is that there are structures are very important consisting of something called setae, and there are hair-like structures, and a smaller one at each setae called the spatulas. So very interesting setae and spatula arrangement is basically there in lizards' legs, where they contact where they directly contact the wall. Now, what is the importance of such structures is that when they come in contact with the wall, the actual setae or spatulas are in very close to the wall material. Now, when it is very close, what is happening is that something called what is normally very insignificant, a force which is insignificant, but when things comes very close, it's significant, called a molecular force called van der Waals interaction, becomes very high, and this becomes the interaction, the leg and the wall interaction become very high, very strongly bound, and then they will never fall. But at the same time, the lizard itself can tilt the angle and thereby changing the distance between the spatula and the wall, and thereby controlling the force. And we try to mimic the same kind of concepts using engineered carbon nanotubes. So called carbon nanotube based synthetic Jaco types. And it works very well. What we found is that a 1 centimeter square area, the carbon nanotube pattern can support 36 Newton force. And it can do n number of times, no problem. There is no kind of sticking issue. So normal tapes, you all know that it will not work if you do multiple times. In a very high shear rate, it will never work. Vacuum, it will never work. But these kinds of issues are not there when you use these kinds of Jaco tapes. So it's very interesting concepts. It can be taken from, it is taken from nature. Using a materials, advanced material, you can implement for applications. So this is one such example. Now, another example, we don't do much on this, but I want to kind of introduce these concepts because this was also a Indian behind this. I mean, the discovery towards this was also led by a research by an Indian called Sajeev John. Now, what is this? So we all know about the butterfly wings and it's colored. And again, the coloring is most not coming from the pigments, but a very interesting structure within the wings of the butterfly. So if I look into one of these wings using microscope, a good optical microscope may work, or electron microscope may work. You can see that very interesting structures, kind of voids, very interesting voids pattern. So the voids here it means the very interesting kinds of structures where the no material is there. You can see that lots of voids in these kinds of structures. Very interesting structure. So called, now we know that this is called photonic crystals. So where the light, a particular wavelength light can pass through and particular wavelength set of wavelengths cannot pass through, depending upon the size of these kinds of space or voids. So then somehow the butterflies have made a very beautiful nano, and these are all of the order of few nanometer, very interesting nano structures within their wings. And then it's not due to any kind of chemicals, but mostly due to the structure. It gets a very beautiful color, and it gets a very beautiful color, and the color what we see in beautiful butterflies. So it's not a chemical, but it's just by structural engineering. And then when the normal light falls on it, it does different way. You know that the sunlight has 7 colors, and some of the colors will allow to transmit, and some of the colors will get reflected. And this is the reason why butterflies see. And this is very interesting concept where the lambda or the light can be used for selective wavelength propagation is something is interesting in our transmission, for example. Now we are all using electronic signals, electrical signals. If I can use that with replaced with the light signal, then our communication will become much faster than what exactly currently we have. So photonic crystal is, the concept of photonic crystal is basically taken from such butterfly wings or such similar arrangements and structures that is found in nature. Another very important material, and not just material wise, but the structure wise also, is spider silk. Spider silk, I don't know how many of you know that, by very high strength, for example, of the order of 1.7 gigapascal, which exceeds steel, one of the toughest material. At the same time, we know the steel is one of the toughest material. So it basically even surpasses even steel. But at the same time, it has an extendability. You can extend it, the spider silk even up to 500%. So very high toughness. And the spider, the way they make these kinds of fibers is really some of the spinning method what we follow. Inside their backside of their spider is their spinning, where the spinning happens. So inside that, they have in liquid solution. We also, in the spinning, it will be normally in liquid solution, and then basically make the fiber. The ejection from its body makes its kind of fibrous structure. And some of them spiders can make 25-meter up to longer spider or spider cells, very high stable, very high strength, and at the same time very high length, very large length. And depending upon the condition, one of the spiders can make 7 types of silk, depending upon what is their application, to protect the egg, or to make to catch their food, or whatever the way they want. So they can make different types of the silk. So you see that the same material, the small creature can make different materials of different strength, of different variety, is very interesting. And the way it is getting the spinning the fibers is almost exactly the same thing what we are using today for spinning technology. So we kind of try to mimic such a fiber, because this is a carbon fiber. You see, if I look into the spider silk, it is just made of carbon, or mostly with proteins of carbon, nitrogen, oxygen, all these light elements. So we kind of try to mimic such structures using carbon materials. And initially, I have to admit that such structures what we made, kind of core shell structures, exactly like what you have seen in fiber, the spider silk, but the mechanical strength was very poor compared to, very much poor compared to the spider silk. Later we again improved further the structure, and then now we are in a position to make large, we know how to make large amount of such carbon fibers via spinning. And this will have a, you see, these are carbon fibers, conductive carbons, very lightweight, non-metallic. It's no, there's no metal. So what will be the application? You can, if you think about the application, which is basically changing our transmission lines, the big transmission lines what we have seen here everywhere, for our electricity transmission, with a carbon based, very light weight element based transmission at the same kind of conductivity as that of a aluminum wire what we are using now, but the much lower weight and very high strength. You see that such application will basically kind of revolutionize the entire transmission thing. So it is possible, and such a high strength, and that kind of concept basically kind of inspired from some of the things as we seen in spider silk. Very interesting answers. So let me go back to one of the other things I showed you about the shell, sea shell. Now we know how to make these kinds of complex structures using 3D printing concepts like 3D printing. You can have a computer aided designing to make and then print them using polymers or so to get the structures. And so one of my collaborators basically kind of try to understand what is the role of these kinds of spiral structures, because particularly those seashells which is found underneath, much below the sea level, which having a very high pressure, they mostly form these kinds of spider kinds of shell. So why such a spider, such a thing, all of them almost made of calcium carbonate, or calcium carbonate and polymer, or the protein assisted structures. So the material is almost same, but the way the shape only matters. And what is interestingly found that the spider can this kind of spiral structures can have high mechanical strength than those made of kind of non spiral, or kind of just simple cylindrical structures. So really the shape matters. What happens is that if you apply a pressure on such as the spiral structure, the way the strain distributed on the surface varies, and it mostly concentrated at the edges. And this is why people use hemispherical structures in for dome-like structures for architectural things to have higher load bearing capacity. So you see a concept nature how made, to sustain the small creatures in a very high pressure environment, creating just by engineering on the shape. And they basically created a very nice structure that we can inspire from that concept to make new structures. And even the same material, you can have a higher strength material just by engineering the shape. So this is one other concept we adopted. We can kind of inspire from nature to make novel structures. But one thing, whenever I say you can get inspired from nature, or you can adopt concept from nature, because we cannot follow the same principle what nature followed, because nature has taken, one thing you need to remember is that nature has taken several years of evolution to get into this optimum state, optimum shape, or optimum size. We don't have that much time to optimize the structure, because this nature might have done this evolutionary or kind of morphogenesis with the years of time, but we don't have such several years to engineer or to come up with a new material, new shape, or evolve the shape into that particular stage. So we want to adopt the concepts from nature, but you have to have technology which works much faster pace, and we can make in large amount. So as I told you, the concept of nanomaterials are interesting by themselves because of many reasons. But for handling them, we need to make large scale structures. So what we ask is that how to make such large scale structures. We can use the same concepts of welding. For example, we all know what is welding. We are seeing, how the things are getting welded, metallic things are getting welded. Now, can we do the same concepts? So like atoms can ball-like structures I have shown you, I told you, can we weld them together? Or tubular structures, can we weld them together to make larger forms or not? And we found, yes, we can in principle do that kind of welding. So without going to the much details about the scientific aspect of welding, we could weld such nanotubes. I told you, right, just nanotube arrangement itself, you can get a very interesting structures, like a very hard, the darkest material made like that, right? Now, I try to connect them nanotubes together, or weld the nanotubes together, using the concept is using some other impurity atoms. But end of the day, what you get is a kind of sponge. Now, what will be the application of such a sponge? So application of such a sponge is that what we found is, this likes oil very much, this kind of a sponge. But at the same time, if I keep a water droplets on top of that, it hates water. And so-called, you can see that the bowl-like water droplet sitting on top of a nanotube sponge. And if I measure the angle, so-called, we call it a contact angle, it is more than 150 degree, so-called hydrophobic in nature. Now, as I told you, it likes oil, and so you can suck all the oil in water, and because of the stability, you can burn the entire oil, but still the material is intact, because this is a very highly stable, thermally stable material. You remember, this is maybe the same thing why in covering the pots, cooking pots, BC 66, the old, very old report recently from Tamil Nadu, they might have used it because of the same thing, very high thermal stability. But now we know why it is thermally stable, etc. But so you can basically suck and burn the oil, or you want to squeeze it. The very, very mechanically robust sponge, you can squeeze the oil and take the oil back. and you reuse them back, and also it's magnetically trackable. Now we have a company based on that, but that doesn't matter. So the concept is why, so why we started such a project, why we thought about such a thing, because most of the time the situation demands us to think about a problem, right? So this is the same thing with the mask thing. The situation basically makes us to think about a particular problem and find a solution using the non-materials or our using our knowledge. So the time when we started such research, that 2010, the Mexican oil spill happened. I'm sure you all might have heard about this Mexican oil spill, used BP oil spill, and this is the oil is coming to the shore, and this is after reaching the shore. And if impact of that into the ecology was so high, and many things got killed, and all these things, all these kinds of huge economic loss, and the ecosystem got affected. So we need to have a solution where we can suck the oil from water very selectively. At the same time, it can in a very high efficient manner. So this particular spongy carbon nanotube structures can very effectively hold large amount of oil, and this was one of the applications we found. So you see, so that such sponges can be developed with different methods using different materials. Like, then instead of atomic welding, we use the concept of covalent bonding between such graphene sheets, and we could get a sponge. So if I look into using a normal eye, this is like a sponge, but if you use a microscope, you can see that atomic layers are arranged in a very nice porous structure. So this is exactly what I told you, assembling or the Lego game with the atoms or atomic layers. So basically these are the layers made of atoms, and these entire material is made of such layers. So this is exactly a Lego game. The interesting aspect of such a sponge is that it can absorb carbon dioxide from atmosphere, and then once you have carbon dioxide absorbed from the atmosphere because of this porous structure, then you can basically convert them into sugars, exactly like plants do. So such possibilities are there with these kinds of porous scaffolds, and it happened because we know how to engineer the atoms and then hybrid structures to form large scale structures. Now this sponge is easily usable. Then the individual nanosheet may be very hard to control and use it, but now with this entire sponge is easy to, there is no training needed. You can just simply take it out. You can, because it's very big. So various different structures of such kind can be developed, and very lightweight. That's another interesting aspect. Very lightweight, and very interesting mechanical properties. So this is something, one such sponge, you can completely squeeze the sponge. It still comes back in the same way. Not only in the room temperature, it works even in a very high temperature and very low temperature. This is an example shown in 900 degrees Celsius. And the same thing works in ultra low temperature, say minus 196 degrees Celsius. So you see, the materials are known to the mankind, and just by keeping them in the right shape and size, you can get so-called an exotic material. It will be very useful for applications. And similar concepts was used in building concrete, for example. So this is also another work we have done a few years back. Selectively absorb oil. At the same time, the brick, because of the nanomaterial, give reinforcement to the concrete. The interesting aspect, we need to apply only a very small amount of nanomaterial. It will give the strength to the concrete. At the same time, it also does another job. If a oil water mixture falls on it, it will filter out only water. Now the next world war is for water. That's what people predict, right? So water is a very important issue, and I'll cover some aspects if I get time in another 5 minutes. But this can filter out water. Concept used, the nanomaterials are used here to reinforce them, and at the same time does another job of so-called multifunctionality, filtering oil. Another important concepts I want to cover is the Lotus effect or super hydrophobicity. Hates water. You all know the Lotus, if I put water, it basically roll off or called hate water, right? Hydrophobicity. Now, if I put oil on that, you can see that it will wet. So the question is like, can we develop such paints? Can we develop such surfaces by ourselves? So here also we studied what is there in Lotus Leaf. Two important aspects. Lotus Leaf also, if I the same way, similar way I did for the butterfly leaf. If I microscopically study the Lotus Leaf, you can see very interesting nano-structured patterns on top of that, on top of the Lotus Leaf. And this is one of the reasons why it gets the hydrophobicity or water hating property to the Lotus Leaf. And it also has a wax coating, but one of the very important part of this water hating part is coming from this nanostructure. Now, what will be the application of such a coating? One such you can see is a self-explanatory. This is a very common habit many of us have. If you have such a hydrophobic coating, you will never do this, right? So I mean, this is a wall in Germany, but this is very kind of jovial way I presented, but it has lots of other applications, because one of the very big energy loss in many industries is via the corrosion. Corrosion to the concrete, corrosion to the metallic parts, corrosion to the ship. So these are huge energy dissipating systems. So can we address corrosion with these kinds of coatings? Here it's water hating. If we can make oil hating too, it will be kind of very nice application. So it will basically help preventing corrosion, very high energy savior for us. We have developed such coatings, various types of coatings using graphene or similar kinds of materials, and transparent coatings, transparent hydrophobicity. So these are very important. You can find ever transparent hydrophobic things. Your solar panel can be coated. You can self-cleaning. Why Lotus Leaf use this thing? Lotus Leaf use kinds of coating because you need to Lotus Leaf want a kind of self-cleaning property. Whatever dust falls on it, they want to clean it. So that is the reason Lotus Leaf has this property. So that kind of applications are there. We also need, for example, in solar cells, we need the cleaning of the surface. So for example, windshield, we want the cleaning. So we want this hydrophobicity at the same time keeping the transmission intact. We don't want to completely hinder the light transmission, because that will affect the applications, affect the visibility of your windshield, but at the same time hydrophobic in nature. So the concepts of such things can be developed. Another one concept I want to cover is a very interesting concept adopted from Stenocora beetle. Stenocora beetle. This is a beetle found in desert. It basically makes water for, harvest water for its own drinking. What it does is that as it goes, condense water on its top, and because of very nice arrangements of its top surface, body surface, the water comes directly into its mouth and drinks it. And this is a very interesting concept. What about if you think about, if you are just walking, collecting fog from atmosphere, and use that water for yourselves, it will be very, very interesting application. So it's not like a very fancy concept. So now we know why such a thing happens in Stenocora beetle. Very interesting array of structural arrangement of hydrophobic and hydrophilic patterns on top of its surface makes this water condensation possible when they walk. And angle is also important. The way it walks is also important. So this basically fog condensation, harvesting the fog from atmosphere is a very effective method in fog collection, particularly in deserts. Like it's already such a concept is demonstrated in Chile desert. So we also kind of tried to develop such a water harvesting system from atmosphere using the same carbon structures. And we developed a hydrophobic and hydrophilic regions. And what we found is that it can basically harvest water from air, humid air. And very interesting other application is that, you all know it gets evaporated. Water will get evaporated from the pot, right? When you keep it open. But what we found is that from such nano pots, from such nano containers, the water evaporation rate is much lower than the typical other kinds of pots. So very interesting, because think about something which can harvest water from air, and at the same time the evaporation rate is much lower than the normal pot. You see, it is something like kind of Akshaya Patra, right? It is very interesting for applications of water harvesting, and it's a very pure form of water. So that's why the concept got lots of attention. Even the Science magazine has featured our findings. So what I want to tell you, that the concept is taken from nature. A simple beetle is found in a desert. This is adaptable to us also for our technology, and use them for various kinds of applications. One last thing I want to cover, I will not go much in detail because I already have 1 hour now. Photosynthesis and the concepts which can adopt from nature. So photosynthesis, I already told you, all of you know that the nature does it very nicely. But if I look into that, how effectively the plants do this photosynthesis, converting carbon dioxide into, of course, it gets to oxygen. That is a catalytic process. It's very interesting. And at the same time, it also makes sugar using this carbon dioxide and sunlight alone. Very interesting process. So that can be definitely, we are all trying to make them in the lab, but a very difficult process because it's a complex process by itself, and it has a multi-step process. Developing that in the lab is not easy. But at the same time, I want to tell you another concept which nature follows. We all know that a metal will conduct, but the things which are electrically conducting in many of these plants and these kinds of system, biological process, are proteins. They are non-conducting in nature. So they are also very effectively transport electrons, that is so-called electrical conductivity, even though they are so-called insulators. So this is happening. So what is now new is that it's because of something called the chirality of the structure. The chirals, all the proteins or all the biological molecules are, most of them are chiral in nature. So the chirality plays a very effective role in electron transport, particularly so-called spin selective electron transport very efficiently. This is a concept. Now it is known as a Spintronics, but I'm not going to the details of that. But you see that what I want to tell you, the nature does it very effectively, not looking into the current, but looking into how efficiently electron can transfer. That is what we are doing in metal also, right? Metal will, how we will see, effectively transport the electrons without resistance. Nature does it very nicely. So this is one of the concepts we can also adopt. Now people are thinking about these concepts in various applications. How, even in being an insulator, how effectively electron can transport just by creating chiral structures. And the photosynthesis is another example I told you. We are trying to do that just by hydrogen and water and carbon dioxide mixing in presence of sunlight. If we can get products, different products, not only sugar, but other products too, it will be very, very interesting for applications. Plant does it, reforestation, making artificial forest, and all are other options for creating, but this will take time. So you have to have our own methods to create our products needed, something like all these kinds of hydrogen, water, sugar, etc. So we need to find out technology for developing some such structures using the same biological concepts that plants follow. So this is what many people are thinking about, how to convert them very effectively. So this has importance in batteries because energy need to be stored, and then this has importance in catalysis because conversion need to be effective, and then the storage of these chemicals, transport of these chemicals, all these things are important. And now we are working, and many labs in the entire globe are working towards this problem. So one last concept, if I have 2-3 minutes, can I use Dr. Anujoy? Can I take two more minutes?
Yes, please go ahead. Please go ahead.
Okay.
Yes, you have.
So carbon dioxide is what we all know. It's greenhouse gas. Why it is a greenhouse gas? Carbon dioxide, the sunlight goes through the atmosphere, absorbed by the earth, and then re-emit it. And when it re-emit it, it mostly of the infrared region, and the carbon dioxide absorb such infrared radiation and re-emit it. So the large amount of carbon dioxide presence in the atmosphere can increase the atmospheric temperature. And in this year, along with last year, that means 2020, along with our pandemic condition, we also hit another milestone, highest level of carbon dioxide in the human history, 417 ppm. So we all know that after effects of these greenhouse effects, like sea level increasing, the weather changing, etc. Fortunately, we have a lockdown, or unfortunately, we have a lockdown for several months in the last year. It has done some good things like making our pollution less, making our cities sky clear, including in Hyderabad. But now that is so why I said, because the carbon dioxide emission is mostly from human beings activities, is because you can see that when the activities were cut short during the March, April, May times, you can see a drastic reduction in the carbon dioxide emission. So that means that the carbon dioxide issues with the carbon dioxide emission are happening because of human activities only. Now we need to so pandemic condition will get almost got over. Now we need to have solutions, long-term solutions, how effectively we can control carbon dioxide emission, how effectively we can find alternative energy sources, because fossil fuels, that is the one of the longest thing what we are using and the highest being used for our energy purpose, energy needs. But we definitely need non-fossil based energy technology for meeting our energy needs. So this is another important aspect why artificial photosynthesis or converting carbon dioxide themselves into useful product by other means of our own methods, which can be make into large scale, are highly important, and research in this scale is important. So because of this carbon dioxide issue, various countries, actually including India, basically pledged a very drastic cut short in the carbon dioxide emission by 2030. We have different plans. One of such plan is National Mobility Mission. We are converting our electric vehicle, our petrol or diesel based vehicle into electric vehicle. But still we are not in a stage to use that, because you all know very simple concept. Your mobile phones need at least 2-3 hours or at least 1 hour to completely charge it, and then you know how long you can use that charge. But at the same time, if you go to a petrol pump or petrol pump and fill your petrol tank, and within 5 minutes you can fill it up, and you can go very long distance with that petrol. That means both energy density and power density of our fossil based fuels are much higher than existing battery based devices. So still we need to go a long way to make into completely battery sustainable world. Again, there are lots of issues in there also. Ideally, we want to use the energy what we get from sun, because particularly in India, we have a good geographical position in the globe, because the right position, we get sunlight almost every time in the year. Can we convert this solar energy effectively into, can we store it, convert into electrical energy and then store it? And then this electrical energy for other sources like hydrogen, a very possible fuel for the future, and other useful fossil fuels. Can we create petrol or diesel using this conversion process? But where the nature does it, but nature takes millions of years to make fossil fuels. So they are also very limited in the earth. So this is one of the research what is going on here. Water is important. I am not going to the details of the water, importance of water, but though 2/3 of the earth is covered with water, only 0.5% is usable for the mankind. Even in that 0.5%, pollution is a big issue. So with the everlasting increase in the population, the water is going to be one of the very big issues for the future. We are India, even India also in the water stress condition. You can see that it's a water stress by 2025. So whole India is going to have a water stress. So water is a problem. Now, the nature does this purification. You can see the natural streams are the purest form of water is available. It does by these kinds of methods like adsorption, aggregation, biotic intake, as they flow through the forest, for example. So can we use such concepts? Can we use such concepts here? Yes, we can use. That is what we are using in our filtration technology. Exactly what nature does, but it has limitation. Very expensive technology, particularly the methods like reverse osmosis, etc. So the sand-based filtration is well known. That is what the earth also does, right? Nature also does sand. So we try to modify the size, but this is not effective in filtering out the metallic nanoparticles, particularly in India's like different places. Mercury is a contamination, lead is another contamination. So can we remove these metallic ions very effectively? And what we found is that by kind of covering, we can cover such sand with a very nice nanoparticles of carbon. Again, this is a carbon materials, and it's also, this sand will basically float on water. You know that, the Ramasetu is a floating brick. So this is like, it's similar to, I mean, I don't want to have any comparison, but what I want to say is that normally sand will sink, but basically this sand will float and absorb the oils. And we found that it can very effectively filter out metallic particles like mercury into that. So water is important. So that's why again, the BBC caught into this. Our article, it was kind of caught attention in BBC because water is important. Any ways to purify water? One of the ways to become a millionaire, I would say, it's to find a good, usable, affordable technology for water purification. Nature does it. Only flowing water through a system. This is in our human body, including human body or many biological systems, something called aquaporins. Aquaporins can conduct water very effectively. So now people have discovered artificial aquaporins in a very high rate. Only water can go through. This will be very useful because only the one of the ways to get water is via purification of the seawater. So because purification of the seawater, now we are doing that, but it's very, very energy consuming and time consuming and also very expensive. Can you use such membranes, very effective membranes as aquaporins does, which can separate all the salt, only permeate water through the system? So this is another kind of active research happening here, and some successes are there. Water, there are membranes people have developed which can have very, very high permeation to only water systems, very high, in a very, very high rate. So I hope I could cover some of the aspects we do, and also what are the challenges in some of these concepts where we can effectively adopt biological concepts and we can implement in the lab. So the problem here is that we can find there is something called the value of death in biology. It's called, what we define in the something in the lab is in the level of technology readiness level, say called one. Once something we discovered in lab, make them to available to the common man for technological development, large scale technological development. You need to cross a bridge which is time consuming, cost, high cost, and also high risk. And then only that when it reaches to technology readiness, so-called 9, then only it is effectively useful to. It takes time to reach into that, but we need to have a very combined approach to reach into that position. But various problems can be addressed by adopting concepts from nature. So my suggestion is observe, learn, mimic, and then give to the society, where we need to know about concepts from physics, chemistry, and biology, mathematics, all kinds of arts, all kinds of field, because this tomorrow is for interdisciplinarity. It is not like the separation like physics, chemistry, biology, and mathematics, etc. are no more there. And we need to work together to address some of these very challenging problems what we are facing now. Then we can have a very bright future. With that, let me thank you. My group, many of the works I have shown is from some of these guys who have done here, who has done. And then special thanks to TIFR and Dr. Anujoy and my student Anugraha. Thank you. Thank you for your kind attention.
Now we can take few questions. There is a question already in the chat box. This is from Santosh Kumar. The question is graphene a conductor or insulator? I'm working on Spintronics. For that, I need graphene. With tape, I have already tried to work, but I need to work on it more. So do you have any suggestions?
Yeah, graphene is a conductor. It's not an insulator. So the first answer is graphene is a conductor. And there are, okay, now graphene is available in large, so I think even in some of the markets. Also, now it's in the, I would say that if I talk about the technology readiness level, it has already reached into the technology readiness level 8 or 9. So it is largely available even for buying. So the graphene, the way the reproducibility, synthesis, etc., is quite known now. Definitely, it also depends like what kind of graphene, because the same name of graphene, there are different types of quality of materials are available. So there are certain parameters you can set for quality of graphene, but definitely graphene is available commercially to buy in large amount. I think I have answered it, right? Yeah.
Yes. Any other question? You can put on the chat box. Yeah, let me. Yeah, there is a question. Can we make nano processors in the future?
Yeah, I mean, the nano processors. Okay, so you're talking about the computer processors, right? All right.
Yeah.
I mean, definitely, we are all, already we are doing the various parts of our CPU, right from memory elements to transport elements as nanostructures. There are some challenges in this field, in the sense like when you create into nano size, heat management will be an issue. But people have found different ways to manage this, and definitely we will have such kinds of miniaturization, and already started. People are working on in this miniaturization in the systems in different forms. So definitely such kinds of processors are can be expected in the near future for applications, for usage, yeah, common man's usage. Yes.
Okay, there is another question. Soap molecules also have a hydrophobic end through which the cleaning of clothes is done. So do you want to comment on this?
This is not a hydrophobicity. This is a soap molecules work in a slightly different way. It is not due to the hydrophobicity of the molecule. The hydrophobicity comes from the surface of the system. It's not from the hydrophobicity. The soap works not because of the hydrophobic nature of the thing, but it works in a different, slightly different way. So it is not from hydrophobicity. That's what I want to comment on that. Yeah.
Okay, there is another question. Aquaporin, is it available? Then why can't we use that in oceans and reduce the problem of drinking water?
Yeah, you see, biological aquaporins, I mean, the concept you can adopt. Artificial aquaporins, people are trying to develop it. But making into a very large scale amount from a biological system, it's not easy. So extracting aquaporins in that large amount, what we needed, is quite challenging to my knowledge. So definitely, aquaporins themselves, I mean, people are trying in different ways, of course, aquaporins for different applications. But to make into the technology using biologically extracted aquaporins, I'm not sure how easy it is. That is why people are going with the artificial aquaporins. So the idea is that, you know, it's the concept of aquaporin can be mimicked or can be taken to make another types of aquaporin, artificial aquaporin materials. That people have successfully done. Okay. Yeah, people are that the same concept. People are trying for water desalination, etc.
Okay, there is another question. They would like to know what are the major research areas in nanomaterials. A related question is, can you please tell us applications of nanomaterials in medicine field?
Yeah. So, I mean, nano is a word, as I told you, it's a word. I mean, this means that the size of the order of few nanometers, say example 1 to 100 nanometer. So this has applications in different fields, from electronics to biotechnology. So in medicine also it has field, because it has interest, because, you know, only with a small amount of materials, it will be useful for therapeutics and also imaging and drug delivery, for example. Another concept called magnetic hyperthermia. The magnetic nanoparticles into the cancerous cells via cyclic magnetic field, you can heat that particular localized positions. So instead of using the medicine based killing, you can use a heat based killing, or very selective, but which is very selective. So you don't need to, it will not affect the healthy cell, but at the same time, very pointed into the cancerous cells. So magnetic hyperthermia also people have tried in different places for applications. So definitely it has applications in medicines in the form of therapeutics, for imaging, and also for applications like magnetic hyperthermia. And so the word nanotechnology, or the concepts of nano, has applications from electronics, biotechnology, medicine, and then even the architecture and building construction. So various fields. So it has kind of diverse applications, where you can find applications by size engineering. You can basically get very interesting aspects of properties. So it has applications, in different fields, for sure.
Okay, there is a question. Can we change the pH of water with nanomaterials?
So pH of water with nanomaterial, so difficult to answer. So just with the nanomaterial pH, the concept of pH, I don't think you can change it. But there are ways to make it non-uniform, the pH non-uniform, with the different materials of with the different nanomaterials via different means. Not just with the addition of nanomaterials, I guess, if it is not surface has any kinds of other, of course, what is pH? The amount of protons, right? So if it is something which can change the concentration of proton within the water, definitely we can. And there are permeation, proton transport membranes available, which can do kind of pH, which may able to make a pH gradient or so. But otherwise, I'm not very sure whether we can really change the pH just by adding nanomaterials or not. But of course, in locally, you with in the very near surroundings of a nanomaterial, there is a possibility of changing the pH with the concentration.
Okay, this is a question for the schools. So please advise an activity on nanotechnology to make our students to understand about it. This is in the high school now, they teach a bit about nanotechnology. So can you suggest any simple activity to introduce this to students?
Yeah. So as I told you, right? So one of the applications of one of the attributes of nano, particularly with these some of the semiconducting materials, is their color changing with the size. Okay, so you can. I mean, the same material, for example, if I take gold nanoparticles of different size, it's not expensive also to demonstrate. You can develop gold having different sizes. Now it's well known. It's not very expensive and it's very easy to demonstrate in the lab also. Just by the same gold, if you just keep the gold after gold nanoparticles or age it, or you can different size gold nanoparticles can be synthesized. You can see that the color of the different the gold having the different solvents having different sizes of gold particles will have different color. So you can ask them, why the color appear, what is the reason for colors of all materials? Because the whatever color is reflected, but the rest of the color they absorb. So the same material, just by changing the color, you can see that the color changes. So color is not a permanent property of a material, but when the size changes, its property changes. So so this may be one of the easiest things. So there are different types. It doesn't need to be gold. There are different types of semiconducting particles available, which can be shown for these applications. So color, I think this is one of the easiest way to attract the attention of students. I guess the way the color changes. So they normally think that color changes because of some chemicals, but it's not chemicals. But just by changing the size, you can change the color. So I think this will be one of the very beautiful concepts you can demonstrate in the lab. And there are many various other concepts also. You can directly take the attribute to the nano, but they may not appreciate it because here it is really visible, because it's application of nano, but the same material which changes the color. So color changing will be one of the things which can demonstrate in the lab, I guess. Yeah.
Okay, there is another question. This question is not very clear to me. Please elaborate if I'm not asking this properly. Saplings have got the magnetic nature when they are grown into nanomagnetic materials. Please explain that.
Oh, what is that? Sorry, I didn't get that. What
Yeah,
is?
so can you ask this question? This is from K. Jnaneshwar. This question is not clear to me also. He's telling saplings have got the magnetic nature when they are grown into magnetic materials.
I don't know. So what I don't know what is happening. Maybe I'm not aware of that. So if they can explain me, I can try to answer. There are, there are certain materials. For example, bacteria, which basically makes magnetic nanoparticles and align them also. Something called magnetotactic bacteria. So this bacteria makes iron oxide very effectively. So this is very interesting magnetic material, and it has applications in water purification, other storage, memory, etc. But I don't know what is this sapling. What kind of sapling it is. So I think okay, I understand. If I don't know whether he has taken the same thing what I have shown in the case of that nanotube, magnetic nanotube. So that basically we injected the magnetic carbon nanotube into the seed, and we try to monitor their transport within as the tree grows. So as when it reaches kind of not really even sapling, when it reaches to a small the kind of plant, we tried to take into the leaf, and we found the magnetic properties, and we track the magnetic nanoparticles, so the carbon nanotube. So I don't know whether he has meant this or not. So this has applications. This has applications in kind of understanding the growth of plants. So if we meant by sapling by this is what we did here. We injected this magnetic and carbon nanotubes into the kind of seeds, and then we try to look into the magnetic properties of the leaf after the growth.
Okay.
Yeah.
So the next question is, when we discuss about nanotechnology, we always listen about carbon nanotube. Why can't it not possible with the atoms like silicon?
Yeah, I mean, definitely there are silicon nanotubes, and it has applications also. So why carbon? Because that element carbon, it's a very highly abundant, and you can directly, the moment one say carbon, even for Indians also, carbon is a well-known element, right? And it's part of our most part of our body too, after water. So carbon, and also it's easy to make, and one of the first nanostructures people have studied. So this is the reason carbon. Silicon also has similar properties. Silicon nanotubes can also be developed. Silicon nanotubes, nanowires, etc. exist. They have applications in batteries, etc. So I took the example. I took the example carbon nanotube because this is one of the things I worked a lot. And carbon an element is very interesting because the same carbon element exists in different forms as a graphite, known even for Indians for a long time, diamond, that is also known to India for a very, very long time. And now other structures, they are very similar to graphite, but in very different properties, like graphene or carbon nanotube or fullerene, etc. So there are, other materials have also similar kinds of structures. So silicon also has it. It has applications, different applications.
Okay. Another question is, we all know that condensation results in water from vapor in air. Is there any machine which can do this? Do we have any such kind of projects in India?
Yeah. So I told you, right. This is the collection from water, from air. Is a concept that is now people are taking up a lot. Actually, this is not a very old concept. We knew about it. So the paper what we published is something almost on one such first article. Uh, so such concepts are important in desert kind of areas, and for collection and water harvesting projects in India. I'm not very sure whether they are there or not, but all over the world there are different places they basically does these things. There are different places um, um, basically use this concept. But in India, I'm not very sure there are is there a very active project is going in any labs or not. But such concepts now people are trying to kind of develop in large scale, particularly in deserts. And the principle is by engineering the surface structure, as I told you, like water liking and water hating region. And now people are studying why such surfaces condense water much effectively than other surfaces. So such projects are going on.
Okay, this is a question that I'm reading. This is from several teachers asked this question. Can we introduce the knowledge of nanotechnology from high school level as a course? Then how can we design a course like that and introduce it to children? This is from, I am clubbing the questions of several teachers who asked this question.
All right. Okay. So, I mean, definitely. So, one thing we should understand is that nano is not a very separate topic. To understand about the nano, we need to have the concepts of physics, chemistry, biology, everything. Okay, mathematics, etc. So, I mean, nothing wrong in incorporating into the student syllabus, but with the high school syllabus. But my worry is that people may get a student may go with a misconception, right? So nano is basically what happens. Nano is what happened to materials when the size comes below this particular sizes. So I think to my understanding, concepts of atoms might be there in nano in the high school level, and definitely large scale structures made out of atoms will also be there. Now we are talking about a size in between between those two things. So it's nothing wrong in introducing the concepts of saying that there is a class of materials where you can, when you bring certain atoms together as a clusters, and in that region of size, say called 1 to 100 nanometer, materials will have a very interesting properties. Nothing wrong in introducing that, but otherwise, to understand the concepts of nano, you need to have a thorough knowledge of physics, chemistry, biology, etc. So still, not only in high school classes. If you ask me, they're very dedicated. Now there are courses like a nanotechnology courses on BSc nanotechnology and MSc nanotechnology, etc. So if you ask me, as a person who works on this area for some years now, I will never recommend anyone to go for such a course. Why? Because this is not that kind of a different topic from what you are learning from physics, chemistry, and biology. So this is something very, very related to that. So you need to understand the concepts of physics, chemistry, biology, and that. It's not a very otherwise going to a very narrow stream will basically end up with not knowing the field much. So you want to so for understanding the field of nano, you need to understand physics, chemistry, biology of materials quite very well. But nothing wrong in introducing such concepts, because now people are talking about nano in nano in different fields, from electronics, from hard drives to biotechnology for imaging and MRI. So that students are almost every day they are facing these kinds of gadgets and kinds of applications. So nothing wrong in introducing these concepts, but in a very wise way, without giving any kind of misconceptions to them. So of course, in some level of high school, you can definitely incorporate the possibilities of size engineering, but I would not go to a very dedicated course on nano at a very small level of class before understanding the physics, chemistry, physics and chemistry of materials. Yeah,
Okay,
so
next.
this is my kind of, yeah.
There is another question. This is about that alkaline water, that machine, Kangen water. Does that Kangen water includes any nano plates?
Which water?
This Kangen water machine, which there are these alkaline water machines. It's a Japanese technology.
Okay. So I'm not very much aware of this particular this alkaline water technology. So I really don't know. Actually.
Okay. Okay. Yeah.
So I mean, I can tell you that there is such nano concepts are now people are, and even in India, the scientist called T. Pradeep from IIT Chennai. His concept using silver nanoparticles in water purification is there in the commercial water purification, some of the commercial water purification systems. So such concepts are already there. I am not really aware of this particular technology. Yeah.
Okay. Another question is, you said that nanotubes can be used in transmission lines. If so, it completely transmits the signal like an optical fiber. How does it work?
You see, so what I was talking about is the nanotubes or nanofibers based transmission lines, which can replace the existing aluminum based cables. So aluminum based cables, metallic cables have a huge transmission loss. We all know that. And the other issue with the aluminum cables is that they are very heavy. That is why we need to have this much large kinds of supports for them. Now, the same concepts can be, if we can replace with a carbon counterpart, the transmission loss can be reduced. At the same time, the weight can be drastically reduced. So the way the transmission lines being developed will be very easier. Now, talking about the optical transmission, the light-based technology is entirely a different concept. Of course, the fiber optic based transmission, whatever we are using in the current day telecommunication, has its own advantage of over the electrical transport. So both are different. So one I'm talking about the electrical signal transmission. The other is about the light transmission for telecommunication.
Yeah. The next question is, can we separate the constituents of a homogeneous solution by using nanotechnology? Like you said, oil can be separated from water.
So homogeneous solution means who are asked can elaborate it? I mean, what do you mean by homogeneous solution? So you mean that completely thoroughly mixed solution of oil and water? Is that the meaning?
No, actually,
yes. Yes.
It's a homogeneous solution.
All right. So if that is the concept, yes, there are ways to separate it. Yes, if the oil water mixture so if the concept is regarding, the question is regarding the oil water mixing very well, even in that mixed solution also it can get separated or not. Yes, it can get separated. And for other kinds of solutions, the solvents extraction, there are nano concepts available. May not be based on sponge, but there are ways to separate those kinds of mixture solutions too.
Okay. There is a question. Can you please give some examples of nanosheet, which is an insulator?
Yeah. So, I mean, for example, like insulator in the sense electrical insulator, a sheet of, say, example, very similar to graphite. There is another kind of ore, it's largely available in India, is boron nitride. So the boron nitride is also very similar to carbon sheet. It is, instead of carbon, it is boron and nitrogen, elements like boron and nitrogen. So this is a very good insulator, and it has applications too. For example, so when I started my independent researcher, one of the questions, one of the companies came to me is by GE, General Electrical. What they wanted is they are the big our electrical transformer manufacturers. They wanted to the transformer wise it's so big because one reason is the oils they use inside that which is being used for thermal management to bring down the temperature or to uniformize the temperature. So they want to bring down the size. So one of the ways to bring down, make the oil more thermally conducting at the same time electrically conducting. So one of the ways we modified the oil is by using such insulating nanosheets of boron nitride, where it is electrically insulating at the same time thermally conducting. So there are insulating, different properties, nano sheets or nanomaterials available having different properties, and then hence according to your problem you can find the material.
Okay, there are 3 more questions. I think with that we will, there is a question on, do you know any application of nanotechnology in effective management for COVID-19 therapy?
Okay. So therapy, therapy as such, I don't know anything about the nano-based technology available currently. But I would say from my own experience, and you might know, Anu might know about our mask. So basically that we have developed is basically using a nanomaterial. So it's not really for therapy, but kind of avoiding the spreading as a personal protective equipment. So I'm not very much aware about the therapeutics, how people use for COVID-19, how effective it will be, which aspect the nano concepts of nano can be brought. But of course, we ourselves use these concepts for COVID-19 in mask concepts of nano. So we modified the existing mask with some kind of nanomaterials to make the filtration of air more effective.
Yeah, this is also a related question. Can we use nanotubes to reduce the air pollution? So,
nanotubes have predicted not only for air purification, but also for water purification. So there are theoretical concepts like when you push water through a nanotube from one side to the other tube of like a PVC pipe, then the other side water will be extra pure, completely pure, only containing hydrogen and oxygen, no salt or nothing. But these kinds of concepts were not really kind of realized other than the theoretical concepts. So it can definitely, because as a membrane, as a filter, it can be developed, definitely used. So in that way, air pollution can be controlled because it can also some extent absorb carbon dioxide. So there are applications, but the question is whether it is reached into the level of where one can use in the existing technology. To my knowledge, it is not.
okay, we will take one last question. Graphene is 1D nanomaterial. Is there any other 1D nanomaterial that exists till now?
So graphene is so it's not a 1D nanomaterial, it's a two-dimensional nanomaterial. So there are n number of two-dimensional nanomaterials available. So another good example I told you, it's a kind of, I told you it's basically boron nitride, right? So another very good example, very recently people have discovered is atomic layer of magnetite, Fe3O4, a very, very common material, magnetic material we all come across. It's magnetite, iron oxide. We actually deal this with in different forms, in rust and all these kinds of forms. Iron oxide also has kind of sheet kind of, we can make them to a sheet kind of morphology. So the answer is there are different types of atomic sheets available, ranging from insulator to superconducting to very interesting magnetic materials. So nanomaterials of 2D shape, 1D shape, and also kind of particles like fullerene kinds of structures are quite a lot available nowadays. And we can have different materials to be in the form of these structures of nano sizes. So there are large enough. So answer is there are different types of materials of different structures like 1D, 2D available in nature.